Hi everyone, this is the gas walkthrough for April 8th. I'm Philip Newman. Today I'm solving Borderlands Sudoku by Bill Murphy. This is a little unusual, but we have normal Sudoku rules, 1 to 9 in each row, column, and 3x3 box. Additionally, we have some diamonds in the grid, and these diamonds tell us about groups of numbers that are the same parity connected by edges. So I'm going to use this as an example and maybe draw it. Sure, I don't know that this is actually going to work. But let's say these were all odd, and these are all even. The 2 is obviously even. So this group is all odd digits, surrounded by even digits. So it's not any bigger than this. If any of these cells were touching another odd, that odd would be part of the group. The diamond tells us the size of the group. So this one has 7 cells, so we would have a 7 there, if that is correct. So that's how that works. It's probably going to be a little easier to understand just doing the puzzle. I deliberately avoided just using this clue as an example, but let's start solving and we'll use it. This is a 3, it's odd. In fact, let's go ahead and just color all of our digits. Blue for even, orange for odd, as is our standard coloring. Okay. This is an odd digit, so this diamond needs to be part of a group of odd digits, and the digit in the diamond is a 3, so it needs to be 3 big. Well, the only way to make a group that is 3 is to use those 2 cells, because of these even digits in the way. But also, if either of these is odd, the group would be too big. So these have to both be even. And now these have to both be odd to finish the box. So that's how that's going to work. And we're going to mostly color. We will be able to fill in digits in the diamonds as we go. But a lot of this is going to be coloring. Let's do the same for this one. So this is another 3. These must be even to prevent it from being any bigger. And let's look at the 4s now. So 4 is even. It's going to have to grow out at least this far, but the last digit could go in either of these cells. However, we can rule out this one because we already have 4 even digits in this row. So we know now that all of these are odd. So this must go this way. That's all the evens in the box, and we also know this is odd or this would be too big coming out of the box. So that's the 4 done. Now in this row we only have 2 even digits, so these need to be even. This 4 is going to work the same way. We have 3 cells here, we need 1 more, but it can't be this one because we already had 2 even digits in the row. So this is odd, this is even, and all of these are odd. Okay, that is the easier starter clues. We can go ahead and get some digits. So we have 4 and 6 here with an 8. This must be a 2. And the same thing here, this 6 and this 8 with this 4. And then these are 8, 6, and 6, 8, like that. That 2 is going to resolve our diamonds here, and this 2 is going to resolve our diamonds here. And that's going to tell us something with this 4. We only have 2 evens, and the only place for it to go is into this box. So these 2 have to be even. And we can resolve those as well from that 2 and the 8 and the 4 in the row. These are 4 and 8, which we can't do yet, but I will go ahead and mark them. All right, 2 surrounded by odd digits. So this must be even, and it's the only even digit that is part of this region. It's a 4, or part of this group, rather. We need 2 and 8 in these cells. And then the 6 can go in either of those right now, so we'll come back to that. These are all odd. These are even, just like up here. We can resolve these though, 4 and 6 because of this 6. And this 4 again has to grow into this box. It's going to give us 8 and 2 and resolve our 4, 8. That is odd. Okay. Now, we could have figured this out from the 2 and the 6 in the box. If this had been even, it would have to be at least 4. And there's no way to get 4 digits in connected to this diamond without using 3 digits in the box, and that would give us 5 evens. So that was never going to work. But now, just from the column, we know that these are all odd. 4's in one of these, 8's in one of these. We can't resolve that yet. 4 is also in one of these. So I'll go ahead and mark that. 8 is in these. 2 has to go here. 6 we can probably place somewhere. 6 is in one of those. Maybe we can't. And those. Okay. So we've got a bunch of unresolved even digits in the middle. That's okay. Alright. Let's go ahead and do some regular Sudoku at this point. We've got a 7 and 9 in the row, 3 in the box, so these are 1, 5, and this is the only place for 3. These are 5 and 7, which means these are 1 and 9, and we can do that from this 9. These are 3, 7, we can do that from the 3. These are 1, 7, and that's going to resolve the 5, 1 here. These are 7, 9. This is 5, 7, or 9, but there's a 5 here, and that means the only place for 5 in the row is there, and that's going to resolve the 7, 9s all the way around. I've been noticing this pattern actually quite a bit, mostly testing my own puzzles. But when you have a pair like this and a pair like this and it gets resolved with a third cell, it is always going to resolve all of the cells involved. If it's that type of pattern. Anyway. I just found that interesting. I keep noticing it. Alright. These are 1, 7, 9. This is not 1 or 7. So this is 9, 5. This is 1 or 7, but there's a 7 there. These are 3, 7, and 9. That one is not 7. That one's not 9. This is not 1. These could still be just about anything for now. 3, 7 there. This is 1 or 5 with 6. This is 1 or 3 with 4. 6 and 9 here. Go ahead and clean up pencil marks at this point. Okay, first question, can this be 9? Definitely not. So the only way to get out of this box is right here. If this were 9, we could no longer get out of the box. So that's not going to work. So it's not 9. It's not 1. It's not 3. If it were 3, that would mean all of these would have to be even. So that's not going to work. It is at least 5. Because we know there are 5 odd digits in the box, and they are all connected to this. So if it's 5, this is even. If it's 7, this is odd. And it has to be connected to another odd digit, which means this is odd, but this is also odd. So that's not going to work. There is something simpler. So let's go look for something simpler before we commit to using that. And we'll color a little bit more. I'm certain there's something else that I'm not seeing. Oh, I haven't used this 2 yet. That is probably important. So this has to be even. This has to be the 4. And that's going to place 4 here. Additionally, these have to be odd. So that has to be 9, which makes that 6. So now it is blocked off. This is going to be 5. Yeah, using all the clues is important, as usual. And I will finish my coloring, because it's going to bother me if I don't. So that 2 is resolved. This is odd, just in the row. This is the only place for 5. These are 1, 3, and 7. So this is an 8, 9 pair, but we have a 9 here. I feel like there was probably a way to do that just with coloring, but I wasn't seeing it. 3, 9 here, so now this has to be 5. And now we have 1, 3 here, so this is 7, 9, 3, 7, 9. Okay, and that's all going to resolve. I'm not going to leave you hanging. I will color that orange. So 3, 7 there, and then 1, 3, 1, 3, 1, 3. And that is the solution. It's a really cool variant. I like coloring puzzles. They kind of feel like doing 2 puzzles in one. Because the sort of coloring shading type puzzles are, I mean, that's a genre of its own. Very common with pencil puzzles. And getting to do that with a little Sudoku thrown in is nice. I like it. I'm also bad at making these. So when Clover and Bill make things like this and I get to solve them, it makes me happy. A little bit of symmetry breaking here, actually. I just noticed. No reason there wouldn't be, but it's a very symmetrical puzzle up to that point. So anyway, I hope you enjoyed it. Let us know how you did in the comments, and I will see you next time.